So lesson 15 is pretty long, so I'm going to try to condense it to get the main points across as much as possible. So on 15.2, it says, let's investigate the inequality x minus 3 is greater than negative 2. So here we have a table where we have different x values, and then we have x minus 3. So if x is negative 4, and I know that I need to do x minus 3, so then I would have negative 4 minus 3, which would give me negative 7. So if x is negative 3, and I'm subtracting 3, which would be moving left on the number line, then my answer would be negative 6. If x is negative 1, so negative 1 minus 3 would be negative 4. If x was 0, 0 minus 3 would put me at negative 3. Positive 1, so 1 minus 3 would be negative 2. If x is 3, 3 minus 0, so that would be 0. Or 3 minus 3 would be 0. I'm sorry. So it says, for which values of x is it true that x minus 3 is equal to negative 2? So for x minus 3 to equal negative 2, that would be here, which tells me that the value of x is 1 for that to be true. On C, it says, for which values of x is it true that x minus 3 is greater than negative 2? So now I have to see which numbers are greater than negative 2, which would be the numbers to this direction. So that tells me that these three values, so 2, 3, and 4, would all give me answers that are greater than negative 2. So I could also rewrite that as, I know that my x value must be larger than 1. And then on D, it says, graph the solutions to x minus 3 is greater than negative 2 on the number line. So there's no set way to do this. I know that I'm working with x values that are greater than 1. So I'm just going to kind of start at negative 1. So if x has to be greater than 1, then I know that my circle would go at positive 1. And since my symbol is greater than and not greater than or equal to, then my circle stays open, so I don't fill my circle in. And I know that everything greater than 1 would be true, so my arrow would go this direction. For number 2, it has 2 times x is less than 6. So I'm going to write that here. 2 times x is less than 6. So if x is negative 4, we would have 2 times negative 4, which is negative 8. 2 times negative 3 is negative 6. 2 times negative 2 is negative 4. 2 times negative 1 is negative 2. 2 times 0 is, of course, 0. And then I move to the positive. So 2 times positive 1 is positive 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. So now I can graph my solutions of 2 times x is less than 6. So I need to look at what x values gives me an answer that is less than positive 6. So I see that everything to this side is less than 6. So that tells me when my x value is anything less than 3, then my answer would be less than 6. So let's do a number line. So I know my circle needs to go at 3. And because it is less than and not less than or equal to, then I know my circle stays open And I know my x values have to be anything that is less than 3 in order for that inequality to be true. So now for number 3, we have negative 2 times x is less than 6. So we complete our table again. Negative 2 times negative 4 is positive 8. Negative 2 times negative 3 would be positive 6. Negative 2 times negative 2. Negative 2 times negative 1. Negative 2 times 0. Negative 2 times 1. Negative 2 times 2. Negative 2 times 3. And negative 2 times 4. So it wants me to graph the solutions to negative 2 times x is less than 6. So when are my answers less than 6? So that would be any numbers to this side. And that means my x value has to be has to be greater than negative 3. So if you notice, it's going from negative 3 towards the positives. So that means my x must be larger than negative 3 in order for negative 2 times x to be less than 6. So we complete our number line. I know x has to be larger than negative 3. And again, it's not filled in. So I know that 3 cannot be a solution, but I know that x has to be any number larger than negative 3 for it to be a solution. So if you notice, the last inequality on number 2 was positive 2 times x is less than 6, whereas this problem is negative 2 times x is less than 6. So if you look at your number lines, you notice that on the previous problem, x had to be less than positive 3, whereas on this problem, x has to be greater than negative 3. And that's because our 2 went from positive to negative, and so that makes our arrows also move the opposite direction. So on number 1, it says, let's investigate. Negative 4 times x plus 5 is greater than or equal to 25. So first we can always check to see what x would have to be in order for it to be equal to 25. So we just solve this like a normal equation using inverse operations. So if I followed my order of operations, I would need to multiply by negative 4. And then I would need to add 5. Since we're solving, we need to work backwards and use the inverse. So first I need to subtract 5. And then I need to divide by negative 4. So we'll move over here. Negative 4 times x plus 5 is equal to 25. So first I need to subtract 5 from both sides. That gives me negative 4 times x is equal to 20. And then now I can divide both sides by negative 4. So when I do that, that leaves me with x is equal to 20 divided by negative 4, which is negative 5. So on B it says, is negative 4 times x plus 5 greater than or equal to 25 true when x is 0? So let's check it. So negative 4 times 0 plus 5 is greater than or equal to 25. So now I do follow my order of operations when I'm testing solutions. So negative 4 times 0 is 0. 0 plus 5 is 5. And is 5 greater than or equal to 25? No. So 0 is not a solution. What about when x is 7? So negative 4 times 7 plus 5 is greater than or equal to 25. So negative 4 times 7 be negative 28. plus 5 is greater than or equal to 25. Negative 28 plus 5 would be negative 23. And is negative 23 greater than or equal to 25? No. So 7 would not be a solution. So it says, what about when x is negative 7? So I have negative 4 times negative 7 plus 5 is greater than or equal to 25. Negative 4 times negative 7 would be positive 28. 28 plus 5 would be 33. And is 33 greater than or equal to 25? My answer is yes, so negative 7 would be a solution. So I know if x is negative 5, that my answer would equal 25. But my inequality is looking for a variable or a solution for the variable that would give me an answer that is greater than or equal to 25. So let's start at negative 8. Okay, so I know when x is negative 5, my solution is equal to 25. And then I noticed when I had x is 0 and positive 7, it was not a true solution. But when it was negative 7, it was a true solution. So that tells me that my x has to represent a number that is smaller than negative 5 in order for it to be true. So x has to be smaller than negative 5 to be true. But since it says or equal to, then I know it can also be or equal to, which tells me that my circle would need to be filled in because negative 5 is also a solution for this inequality. So I need to fill my circle in, and my arrow would point to the left because any number to the left of negative 5 or less than negative 5 would also be a solution to this problem. So in negative 2, first it sets it equal. So we have 4/3 times x plus 3 is less than 23/3. So first we can solve for x. So first I'm going to subtract 3 from both sides. So that leaves me 4/3 times x is equal to 23/3 minus 3. So in order, I want to leave this in an improper fraction since I know I'm going to be working with another fraction shortly. So 23/3 minus 3, so I want to change that to a fraction. So if I'm working with thirds, then I know 3 is equal to 9/3. So 23/3 minus 9/3 would give me 14/3. So then 4/3 times x would equal 14/3. And now since I am multiplying by 4/3, I can divide both sides by 4/3, or I can use my multiplicative inverse and multiply both sides by 3/4, which is the easier option for me because I know that if I have a 3 on bottom and 3 on top of my fraction when I'm multiplying, then those cancel out because it's just equal to 1. So x is equal to 14/4. Or I can also write that as 3 2/4, which is also 3 1/2. Or I could do 3.5. So this tells me that 3.5 or 3 1/2 is something that we refer to as a boundary point. So I know that when x represents this number, then that gives me a solution that is equal to 23/3, and I'm looking for a solution that would be less than 23/3. So in order to determine if my x needs to be greater than 3.5 or less than 3.5, I need to test a solution that would be on each side of the number line to 3.5. So for B, it wants us to know if this inequality would be true if x is 0. And I know that 0 is less than negative 3.5. So that would tell me if less than would be my correct option. So first we'll test it. So 4/3 times x, which is, we're going to use a 0, plus 3 is less than 23/3. So 4/3 times 0 is 0. And then 0 plus 3 is 3. And is 3 less than 23/3? My answer would be yes. So then I know that x has to be less than 3.5 in order for it to be a true solution. Okay, so I'm going to start with, let's do -1. I'm going to go by half since I'm working with 3.5. So negative 0.5 would be 0, and then positive 0.5, 1.5, oh, nope, sorry, 1, 1.5, 2, 2.5, 3, 3.5, and 4. And this pen does not want to write my 5s well. So I know my circle needs to go on 3.5. And my inequality is less than, and it doesn't have an or equal to symbol at the bottom. So my circle needs to be open. And since 0 was a solution, and 0 is less than 3.5, then I know that my arrow needs to go to the left, because anything that is less than 3.5 would be a true solution for the inequality. So now it just gives us one more inequality to solve and then graph the solution. So you can always set it up as an equation first to solve it, or you can just leave it in inequality form. So we have 3 times x plus 4 is greater than 17.4. So first I'm going to divide both sides by 3, or you could use the distributive method. Either one works. If I divide by 3, then that just leaves me with x plus 4 is greater than 17.4 divided by 3, which is 5.8. And then I need to subtract 4 from both sides. So that tells me that x needs to be greater than 5.8 minus 4, which is 1.8. And then I want to check that to make sure. So I want to check a solution that is greater than 1.8. So we'll use 2. So 3 times 2 plus 4 is greater than 17.4. So order of operations now, since I'm testing. So 2 plus 4, because I do parentheses first. So 2 plus 4 is 6. And 3 times 6 is 18. And is 18 greater than 17.4? Yes, so then this would be my true solution. So if I graph my number line, I'm going to erase some of this now to get it out of the way. So let's just start with 0, and we'll do 0.2, 0.4, 0. I know that looks really sloppy, but it's kind of hard to do on the iPad. So I know that my x has to be anything greater than 1.8. Again, it's just greater than, not greater than or equal to, so my circle stays open. And if you notice, your arrow is pointing to this direction, so anything larger than 1.8 would be a solution. So if you look at your summary, it's telling you that there are different ways to solve inequalities. So one way would be to write it as an equation first, and then that gives you your boundary. So your boundary tells you what number on your number line that you will have your circle at. So, for example, for this problem, they got x is equal to 2, so their circle was at 2, and the inequality symbol did not have the or equal to, so that tells them that their circle is left open. So now to solve the inequality, they would check a number that's greater than 2 and a number that is less than 2, and see which one makes it true. So in this situation, they tested x is equal to 5, and when they tested that, it gave them a true response because 0 was less than 18. So that tells them that x equals 5 is a solution. And when we solved the equation, we got x was equal to 2. And since 5 is larger than 2, that tells us that any x variable that is greater than 2 would be a solution. One way to also solve inequalities is to solve it just like an equation without rewriting as an equation. And know that if you multiply or divide both sides by a negative number, then your symbol flips. So if you look back at number 1 here under 15.3, if you notice in the inequality, it was originally greater than or equal to, but since we had a negative number times our variable and we had to divide both sides by a negative, then when we solved our inequality, we actually had to write it in the opposite direction. So before, our inequality was greater than or equal to, but when we solve for x, since we had a negative, it's actually less than or equal to when we graph it on a number line. And then on number 2, it was originally less than. We were working with a positive number here. So since it was positive and I didn't need to multiply or divide by a negative number, then my solution stayed facing the same direction. It did not change. So your steps are honestly the same as working with an equation, except when you multiply or divide both sides by a negative, then your sign needs to change. So if it was originally greater than, it would become less than. If it was greater than or equal to, it would be less than or equal to, and vice versa.